Hey guys, this is Todd from Espresso Machines. Today I want to talk to you quickly about boilers, and specifically the boilers inside of our machine. I've got two boilers here to show you. You can see inside of our 1GR machine right here, this is the side view, and you can see the heating element and all the electrical and all that fun stuff. But this is the actual boiler that's in it. We chose copper, and the reason why we chose copper is a much better transfer of heat. It conducts heat better than any of the materials you could use. If you're going to choose a material for a boiler, it's ideal. Not only that, it's corrosion resistance. It actually gets, when you see copper and gets a patina, like a greenish patina on it, what it's actually doing is corroding naturally. That little bit of corrosion actually protects the metal. So it's actually not a bad thing to be corroded a little bit when you're talking about copper. But what we did for a couple of different reasons, we coated our boiler using a high temperature polyester powder coat. So it's actually been oven baked. It makes it very pretty, it's very shiny. Not only that, what's cool about it is it does add a little bit of a layer of insulation. So a little bit more thermal stability because we have an actual coating that encapsulates the whole boiler. But mostly it's a pretty factor. It doesn't, down the road, if you're working on the machine, it's much easier and cleaner. Even if you get a little bit of water or water staining, it comes right off. But we also, I want to talk to you what we do that's different than anyone else. We do a direct group to boiler connection. You see this flange on the side. It's harder to see in here. You can see it in some of the photographs on our website. It shows some detailed pictures of the inside of the machine. But what it is we've got a flange that's actually been silver brazed. It's a piece of brass. It's been silver brazed to the boiler. So we have a direct connection to the actual machine. And what also enables that to be better is you have a direct connection to your group. This is that 22-pound solid brass group. And you can see here, this is the idea, is it's married directly to it. So the flange meets up to the actual boiler. What that does is you get a perfect thermal stability. The heat transfer is much more consistent. A less expensive way of building a machine would be to simply build a machine without this flange, and you would run copper lines from the head to the actual boiler. Although that's faster to build, less money, you don't have to build a boiler flange, it doesn't transfer the heat near as good. We also do a direct dip tube into the boiler. So when we are actually connecting the boiler to the head, we also have a draw tube that draws from the bottom of the boiler. We feel like that's the most traditional and the best way to transfer the heat. It's most direct. We feel like it makes the best coffee. That's what our tests have proven. Also, what we do, all the fittings you can see here, they're actually hand brazed onto the actual boiler itself. Each fitting, each threaded fitting, these marry up to our hand brazed fittings as well, metric fittings. They're actually BSPs. Technically, they're not metric. They're British standard pipe, but we can go into that a little bit more on the next video. I'll talk to you about fittings and why we chose the ones we did. But for now, I just want to show you this. It's pretty exciting. We feel like we've done a great job of transferring heat, also making the pretty factor, which is a huge thing for service techs and myself included. When I open a machine up and it looks pretty, I have definitely more pride in it when working on it down the road. Thanks for checking us out and spending the time.